Okay, hello everyone. So, I'm going to discuss example 8. Figure below shows an aluminium rod. So, this is the aluminium rod with radius 5 cm. Okay, so this is the diagram, but I enlarged it here. So, the orange color here is the aluminium rod. Okay, so the radius of the aluminium rod is 5 centimeter. Having a clearance of 0.02 millimeter. What does it mean by clearance? Okay, clearance is like a gap, space. Dia ada space, ruang kosong. That's what it meant by clearance. So the clearance here is here. So the clearance is 0.02 millimeter. Completely around it within a hole in a brass plate. Okay, so as you can see, there is a hole of a brass plate. Okay, yang warna biru ni adalah hole of a brass plate. Hole of brass plate. Okay, and this is brass plate lah. At 20 degrees Celsius, which means the original temperature is 20 degrees Celsius, the initial temperature. Okay, given the coefficient of linear thermal expansion, coefficient of linear. So, linear, so alpha of brass and aluminium are 1.9 times 10 to the power of negative 5 per degree Celsius and 2.4 times 10 to the power of negative 5 degrees Celsius. So, this is the coefficient of thermal expansion for brass plate, and this is the coefficient of thermal expansion for aluminium rod. Okay, what the question want us to find for? Calculate the lowest temperature. The lowest temperature if both metals are heated until the clearance is 0. If both metals are heated until clearance is 0. Okay, until there are no more gap, no more space. Tak ada ruang kosong. So means aluminium tu dah fit perfectly dekat brass plate tu punya hole, dekat brass plate tu punya lubang. Okay, so bila clearance dia dah kosong, maksudnya mereka dah jadi macam satu sistem lah. Memang mereka dah satu sistem. Okay, they are in one system already. Jadi, now in order for us to calculate the lowest temperature, which is the final temperature, we can solve it either linearly ataupun secara area. Secara linear expansion ataupun secara area expansion. Up to you. Okay, but Miss akan ajar untuk solve secara linear. So ada dua cara, linear dan area. But at the end of this video, Miss akan letak solution untuk area. Okay, mari kita continue. So dia expand, Miss kata expand secara linear. Length dia akan expand. Okay, so length dalam case ini adalah radius itu sendiri. So radius dia yang akan expand, which mean the radius of the aluminium and also the radius of the brass plate. So kita dah tahu radius of aluminium ini adalah dia punya initial radius, which mean dia punya initial length. So initial length of aluminium adalah 5 cm. So in order untuk tak membuat korang confused, dia expand in radius, which Miss assume actually radius itu pun adalah length. Dan what about the radius of brass plate? Okay, the initial radius untuk brass plate adalah awak kena tambah. Okay, radius untuk brass plate awak kena tambah 5 cm tambah dengan 0.02 mm. So, awak kena tukar awak punya centimeter and millimeter ke SI unit, which is in meter. 5 cm tukar ke meter, awak akan dapat 0.05. Millimeter tukar ke meter, awak akan dapat 0.00002. So, therefore, awak punya radius of whole of the brass plate is 0.05002 meter. Okay, itu adalah dia punya radius. Okay, so we know the radius of the whole of the brass plate is 0.05002 meter. So this is the original length for brass plate, which is 0.05002 meter. Okay, so the question asks us to calculate the lowest temperature if both metals are heated until the clearance is zero. So here is the key word. Clearance is zero means the aluminum rod will expand, and the same goes to the brass plate. So now both brass plate and aluminum rod will have the same radius. So radius of aluminum and radius of the brass plate is the same. So as I said, I'm using length, so therefore length of aluminum is the same as length of brass plate. And we know the formula of length. Changes of length equals to coefficient of linear expansion times initial length times the change in temperature. And change in length is final length or new length minus original length equals to coefficient of linear expansion times original length times changes in temperature. So now I'm going to bring the original line to the right hand side. So now I'm going to factorize the original length or the initial length. So we will get initial length times coefficient of linear expansion times the change in temperature plus 1. Therefore, as we know, this is the new length or final length. Final length, and this is the original or initial length. And we know final length of aluminium and final length of the brass plate is the same. So we just going to substitute this equation into here. So original length for aluminium times coefficient of linear expansion times changes in temperature, coefficient of linear expansion for aluminium times change in temperature plus 1 equals to original length for brass plate times coefficient of linear expansion for brass plate times change in temperature plus 1. Now here we only need to substitute the value. Okay, the original length for aluminium is 5 centimeter, but I'm going to change it into meter. You will get 0.05 meter. Coefficient of linear expansion for aluminium is 2.4 times 10 to power of negative 5. Okay, we are going to look for the change in temperature first. Why? Because change in temperature, we know it is the final temperature minus the initial temperature. As we are going to look for the final temperature and we know the initial temperature, now we are going to look for the difference in temperature first. Okay, plus 1 equals to the original length for brass plate, which is 0.05002, and times the coefficient of linear expansion for brass plate, which is 1.9 times 10 to the power of negative 5, and change in temperature plus 1. The change in temperature for brass plate and also aluminium will be the same, as both is in the same system. Okay, now here comes the mathematic part. When you solve this, you will get 1.2 times 10 to the power of negative 6 changes in temperature plus 0.05 equals to 9.5038 times 10 to the power of negative 7 times changes in temperature plus 0.05002. Now rearrange all this equation. You will get 0.05002 minus 0.05 equals to 1.2 times 10 to the power of negative 6 changes in temperature minus 9.5038 times 10 to the power of negative 7 changes in temperature. Then you will get 2 times 10 to the power of negative 5 equals to 2.4962 times 10 to the power of negative 7 changes in temperature. So the changes in temperature you will get 80.122 degree Celsius. Now, from here we already know change in temperature, and we know change in temperature is final temperature minus initial temperature. Means new temperature minus the original temperature, and the difference in temperature is 80.122, and we are going to look for the new temperature, which is the lowest temperature, and minus with the initial temperature, which is 20 degree Celsius, which is 20 degrees Celsius. So therefore your new temperature, your final temperature, or the lowest temperature is 100.12 degrees Celsius. So that's all for this question. So I solved it linear expansion, in linear expansion, but after this I will show you the solution for area expansion. Okay, thank you so much. Bye bye.